Okay, so these are the topics that you have to learn in the grade 11. So I'm planning to finish these things by the end of the August, right? So we will be able to start the paper discussion like from September, right? So I'll try my best to finish things as quickly as possible, so then we can have a solid revision in period with the past papers, so which will surely gain you the highest marks, right? So the first lesson is the programming. We are going to learn the programming concepts, and we are going to do some programs, create some programs using the Pascal. And then the second lesson is system development life cycle. It's a small lesson, right? And the internet and the electronic mail, something that you know. And then the use of multimedia, a very interesting practical subjects, right? So the practical lesson and the web designing. And the last one is the information and society, right? IT and society, ICT and society. So today we are going to learn about the programming, right? So people, grade 11 is officially starting, right? So please have the heading programming. Right, now when it comes to the programming, first thing we have to understand why we need such thing called programming, right? So we know that the computer is a device, and the device, a device which can use to solve some problems, some computations, some logical things. The CPU is having two particular components, actually one specific component called ALU, arithmetic and logic unit, which is capable of solving the logical transactions or the logical operations and the arithmetical operations. So through the programming, what we are trying to do is we are trying to create the instructions for the CPU to understand and solve it on behalf of us, which will make our task easy, right? So that is why we are learning the programming, so we can create different kinds of applications or different kinds of programs which can given to the computer and asked to solve it on behalf of us. So our workings, our effort will be reduced and the time will be saved, and we will be living an easy life when those things are happening, right? Okay, yes, that's it. It's kind of a definition that you have given here, all right? So every programming is based and is there to solve a particular problem, right? So when we are writing a program, we always concentrate on to solve some particular problem, and to solve that particular problem, we have to understand what are the inputs, what is the output that we need, and how we are going to process the inputs to take the output, right? So basically, it is fixed into the model input, process, and output, right? So in the book, they have given you some examples regarding like how the things are, like how a problem can be analyzed to have the inputs and to do the process and to have the output, right? So a simple offline example that they have taken, like preparing a letter which can be posted now. This example cannot be illustrated as a program. This is there to identify or to understand how we are going to figure out the inputs, how we are going to figure out the outputs, and how we are going to figure out a process which is taken from the inputs to their output, right? Okay, so yeah, Tesandu, it's the new lesson of grade 11, which is the programming. It's only the topic that we have written. So take it down. All right. So let's move to the programming part. I'm sorry, the analyzing the problem, right? So what they have taken, the case study that they have taken is like preparing a letter which can be posted. So the problem is simple. We have to prepare a letter to be posted, right? So the inputs are going to be a sheet of paper, right, which is suitable to write, and you need a particular pen, and you need envelope, stamps, and glue, right? So those are the things that we need to prepare what we are expecting to prepare, right? So we need to prepare a letter. To prepare the letter, the things that we want can be categorized as inputs, right? And there is a way that these inputs are being made into an output. So we take the paper, we write the letter, we fold it, we put it inside the envelope, we paste the envelope, and we write the recipient address on the envelope, and we stick the stamp, right? So it is simple as that. So our problem was creating a letter. Our solution, or like our process, is what are the things to be done to create that particular letter. And since they have given some steps which has to be done as the process, now can we do the second step without performing the first step? Can we do that, people? No. Yes, Udamya, we won't be, right? Like without writing the letter, if we fold it and put inside the envelope, then there won't be a letter because no content inside the letter. So first, it is a must to write the letter. Then we are going to fold it and put inside the envelope. So there is a way that the things are going to happen. And this case is not going to be as same in every places. Even though we must do the first step to form the second step. Now think about this fourth and fifth steps. Or like again, you can say third and fourth and fifth steps. Can we change the order of those? Yes, people? Like if we look into it more carefully, we can change the order of second, third, fourth, and fifth, everything. Writing a letter at the first point, it is a must. So can we, hold on. Yeah, there is a constraint. Like we can't do the third one without doing the second one. But before we do the second and the third, can't we perform the fourth and the fifth? Yes, people? We can, right? Yes. Just a second, people. Yes, so Anyone who can arrange the things? Like after the first one, what is the step that we can perform? Yes, people?
Yay! This is fun, Dad.
Suhara, that is doing a class.
This is fun, Dad.
Yeah, let me hold on a second. Hold on a second.
Today.
Yeah, sorry for that, people. got to go to my little one. Right. So yes, Tesandu. So Tesandu is proposing first one, fourth one, second one, third one, and the fifth one. Yeah, and he has proposed two ways. 14253, then 14235. Yes. So after writing the letter, without fold, like before we fold it and put it inside the envelope, before we paste the envelope, we can perform either the fourth one or the fifth one, right? We can write the recipient address on the envelope. We can stick the stamp. So that means we can do the first one. We can do the fourth one, right? And we can go for the fifth one as well if we want. Then we can fold it and paste the envelope, right? So like there are different kinds of orders that we can do. So what I need you to understand is there are ways that you can perform a particular process, and it is not just one way, it has many ways to do that. So these things are told as alternative approaches, or like the alternative solutions for a particular problem. Hirumi, yes, again, as you say, 4, 5, 1, 2, 3 all can be done. Writing the recipient address on the envelope, stick in the stamp, then you can write the letter, fold it and put it inside the envelope and paste it. Simple as that. It is also possible. All right. So likewise, for a particular example, we can give a solution by using different approaches. All right. So look at the second example. They are talking about making a cup of tea, right? So what are the inputs they want? It's a plain tea that's they are talking about, not a milk tea. So we need tea leaves, sugar, and hot water, right? So we can put the tea leaves into the strainer and pour in hot water to the cup through the strainer, add in some sugar to the cup, stirring it well with a spoon. And this has something new. Testing for a taste, taking a small sip from the cup. If the taste is not satisfactory, go to the step 3, repeat step 4 and 5. Right? So here, some particular steps can be repeated. Right? In the earlier example, we didn't find anything to repeat. Only the order is changed. So somehow it should start from some particular one. So orderly, we have to close the work, or like we have to finish the work. But here, depend on some condition. So what is the condition here? Whether the cup of tea is tasted or not. If it is tasted, we don't need to do, we don't need to do the repetition. If it is not taste good, we have to do the 3rd, 4th, and the 5th steps again and again until the tea getting up to its tasting level. Right? So here you have some steps to be done again and again until some condition is satisfied. Right? So look at the third one. So they are going to divide 40-page and 80-page books from a parcel of a book between 2 siblings, Sanduni and Anupama. So Sanduni is going to receive 40-page book, and the Anupama is going to receive 80 pages books. So it's a bundle of books. So there can be several 40-page books and several 80-page books. So we have to open the parcel. We have to take a particular book and we have to check whether it is a 40-page book or not. If it is a 40-page book, we are going to hand it over to the Sanduni. If it is not a 40-page book, we are going to hand it over to the Anupama. Or else you can check the condition in the other way around. You can take a book and see whether it is an 80-page book or not. So 80-page book goes to the Anupama. If it is not an 80-page book, it's going to give to the Sanduni. Right? So condition can be defined in many different ways. Right? I have defined 2 ways conditions over here. Right? One way is saying that the 40-page book is less than, a book is less than 40 page or not. Or in the other hand, we can say a book is less than 80 pages, like more than 80 pages or not, right? Or like we can go for the exact thing, whether a book is a 40-page one or not, or else we can ask the same thing, whether a book is 80-page one or not, right? So still it's going to give us the same output, right? If we take the first condition, if the book is not a 40-page, if the book is a 40-page or not, if it is a 40-page, it goes to the Sanduni. If it is not, it's go to the Anupama. If we take the condition, if is the book has 80 pages, if it is yes, it's going to the Anupama. If it is not, it's going to the Sanduni. So at the end of the algorithm, somehow Sanduni is going to have 40-page books and Anupama is going to have, Sanduni is going to have a 40-page book and Anupama is going to have 80-page book. So here you have three particular things that you can understand. In the very first example, we had only instructions happened one after the other. Generally, we call them as a sequence of instructions. And in the second one, they had something to be done again and again. So when something, or when one particular expression or few particular expressions or steps to be done again and again, we name it as an iteration or a repetition. And here we had an iteration as well, because like we take a book and we check it, whether if it is a 40-page one, it goes to the Sanduni, and it is 80-page one, it goes to the Anupama, right? And that is just regarding one book. So if we are considering a stack of books, we have to consider the second one as well, right? So likewise, until the book bundle ends, you have to do this particular path or this particular way iteratively, as well as when you are choosing whether it is 80 or not, or 40 or not, that defines that you have a selection to do. අපි තෝරගන්න ඕනේ පොතක් 80 ද 40 ද කියලා. So it's a selection. 80 නම් එක දෙයක් කරනවා, 40 නම් එක දෙයක් කරනවා. Then ask for another one. So if it is 80, you take one. If it is 40, it needs to be take one. Ravindu, මෙතනදී question එකට කියන්නේ scenario එකට අනුව රවින්දු කතා කරලා තියෙන්නේ 80 page, කියන්නේ bundle එකේ තියෙන්නේ 80 page and 40 page books විතරයි. right, එතකොට 40 page එකක් වුණොත් ඒක සඳුනට දෙන්න ඕනේ. 80 page එකක් වුණොත් අනුපමට දෙන්න ඕනේ. Got it, got it, Ravindu? Right. Okay, so something related to the mathematics as well as the programming. So here the problem is adding two numbers together. So inputs are going to be two numbers. Process is going to be add those things, and the total is going to be the output. Right? So that kind of a program can be worked out through a computer very easily, right? We are going to see how that is happening. And the fifth one, they are talking about the calculating the area about a rectangle. And here we can give several different alternative solutions, right? So if we are going to find the area, it is only this that we can take. But if we are talking about the perimeter of the square or a rectangle, we can define perimeter in different ways, right? Either we can say take the length and the width and add those things 2 times, then you are going to have the perimeter. Right? I think they have put that example as well, as I remember. No, they have changed it. Right? Or someone can say add up the height and the width, then output that particular perimeter, right? So when it comes to the area, we don't have a lot of options. We must multiply the length by its width, right? So likewise, we can give a lot of examples, right? So let's write about this thing in a very short form, people, because we are going to do some practicals through this, right? So have the idea, say, in programming. Right, then you put, yeah, don't put any heading. You can write it under like this, point by point. So you can write the highlighted part. So once you are done, let's write about only 2 examples. So it's better you write the, without writing the first example, it's better we go with the one which has all the things, right? So when you are done, let's tell me, then I'll tell you what to be written. Let me know when you are done, people. Okay, one is done. How about others? Okay, is there anyone who is still writing? Okay, Ravindu, hurry up. All right, Ravindu, are we done? Can we move forward? All right, so as the example, yeah, let's go with this. So write down this as example. Let me know when you're done, people. Yes, are we done, people? Okay, two are done. Others, hurry up. Okay. Right. Anyone who is still writing? All right, so I'm moving forward. And yeah, people, before we move forward, I need you to highlight some of the things, some particular new terms. I'll tell you what are those, right? So yeah, let's do it like this. I'll mark it on the screen so you can write it accordingly. So for the first two steps, it's better you say sequence. Sequence, right? And yeah, for these two, you can say selection. And for the last one, you can say the iteration or repetition. right? It's better you indicate this. I'll tell you what are the meaning of these things. Yes, are we done, people? Okay. Yes, Lamai, just for the record, can I know the people who are participating from Nanapetha Institute? Just raise your hand so I can capture. Yes, it's Dasit. And who else? From the Nanapetha Institute? Okay, it's only Dasit. Ah, Sasrika? Oh, Sasrika. Sasrika, I think. Sasrika, yes. Is that all? Okay. All right. Right. Thank you very much. All right. So we are going to write. Okay, let me clear these annotations. So yeah. So I want you to concentrate on the 7th one. No, let's go do it like this. Let's go with the 4th problem. That means as a second example, just write down this particular one, add in 2 numbers. That will be the second example. And then you can mark all the things as sequence. Even in the previous example, if we think about the input and the output, those are sequences, but since there is like a lot of steps in the process, that's why I have separate only those instructions into what is sequence, what is selection, and what is iteration. So you can write the 4th problem as the second example, and you can indicate it as sequence. Yes, that's it. That can be taken as the definitions of sequence, selection, and the repetition. Yes. Right. Are we done, people? Right. And as the third example, yeah, we can write the last one, the very last one. Finding whether the number is odd or even. Yeah, I want you to look at this because I didn't go through this. I was stopping by the fifth or sixth one. So here they are trying to figure out whether a given number is odd or even. So what they are doing is they have taken the number as the input and they divide it by 2. And then you have to decide whether the number is even if the remainder is 0, or like we have to decide if the number is odd if the remainder is 1. Those will be the conditions, right? And then as the output, we can indicate whether the number is odd or even, right? So write this as the third example. Yes, Tesandu, even means iratte, odd means otte. Yes, that's correct. Right, for that, these two can be taken. The student who have joined recently, I think the name is Pasan. Are you from the Nanapatha Institute or the IEME? It's Yasiru. Ah, okay, it's Yasiru. Yasiru, you are from Nanapatha, right? Right, okay, right, okay. Tisaga, yes, you joined today, right? Yes. Okay, okay. Tisaga, you are from IME or like?
No, I don't know what actually.
You just have you just called me and had the information from myself?
Yes, sir.
All right, okay. That means you are from my institute. That means from Starlabs, because we have students from 3 separate institutes. Doesn't matter. Doesn't matter. I was just having the count Like the people are from the Nanapetra, IME, and the myself. Right, so this can be written as sequence. And these two things can be named as selections. Right, the output is going to be again a part of the sequence. They don't have an iteration here, right? Let me know when you are done, people. Right, one is done. How about others? All right. Is there anyone still who copying this? Right. So I'm going to move forward after clearing my annotations. Okay. So I think we have talked about the alternative solutions. That is the first thing that we discussed with the very first example, that we can approach a particular solution in different ways. එක විදිහට solution එකට එන්න පුළුවන් කියන එක. So those are called the alternative solutions. They have given some examples. We don't need to go through. We have discussed it. Like I want you to have the concentration on this particular thing. Like they have shown, like in the process of taking a perimeter, which I was talking about, we can have the solutions like this. So the first solution can be take like length plus width, and again length plus width will give you a perimeter. The perimeter කියලා කියන්නේ. Right? So the second one, we can do it like length into 2, at the solution with width into 2. And the third solution, we can take length plus width into 2. Right? So all the solutions are going to give you the perimeter, the same value, but the approaches are different. Right? Okay, so let's not write about these things. We have the idea. So I'm going to go to the problem solving using algorithms, right? So now you are going to learn about the algorithms. Here we are having some more examples regarding the alternative solutions, right? So this one is to take the marks and output whether a particular student is fail or pass, right? So to do that, what we have to do is like comparing the marks scored with 35, right? So they, in one way that they can compare is if the marks is less than 35. So when the mark is being input, it will check whether it is less than 35. So if it is less than 35, they take the results as fail. If not, they take the results as pass. And someone can have the condition like if the mark is 35 or more than 35. That means like more than or equal to 35. Right? So if the mark is more than or equal to 35, the result is given as pass. And if not, the result is given as fail. Right? So the output will be the word fail or the pass according to the marks that they are inputting. So the same input, same output again, right? When the marks are given, it will show whether you are pass or fail, but the approaches, the solutions are different. And in the third one, like finding the larger number from the given two numbers, right? So you are asked to give two numbers. They consider that two numbers as N1 and N2. Like these N1 and N2, these kind of things are called variables in programming. Like without taking N1 and N2, you can consider the first number as the X and the second number as the Y. Since we don't know which kind of numbers that the user is going to input, right? Api program එක ලියලා numbers දෙකක් ඉල්ලුවම අපි දන්නේ නැහැ මොන number එකද. Then මෙතනදී purpose එක තියෙන්නේ to find out the larger number. So we don't know whether the user first input the larger number, then input the smaller one. Or in some other case, user can input first the smaller number, then the larger one. So we have to figure out what is the larger number out of the numbers that given by the user, right? So the best way, the simple way that we can do is, right, we can recognize, we can give some variables to indicate the first number and the second number. Then we compare those two numbers. If the first number is larger than the second number, then the first number is the biggest one. If not, the second number is the biggest one. right? Or else we can check whether the first number is less than the second number. If it is yes, second number is the larger one. If not, first number is the larger one. Right? So likewise, as we talk, we can came up to the alternative solutions in different approaches. All right, so people, before I'm going to the moving to the algorithms, is it clear up to this point? Everyone? Okay. Right. So I'm moving to the algorithm part now. This is what is programming is all about, right? So as I told you, before we code, before we use a programming language, first we have to have a plan of how we are going to do this. So in the earlier pages, we just talked about how to figure out these things. Now, when it comes to the programming, there is a way of illustrating our solution to be converted that to a program, right? So the plan that we are making is called an algorithm. That algorithm can be presented as a flow chart, that means as a graphical method, or as a textual method, right? For the graphical mechanism, or like the way that we are using some kind of symbols and all these things to illustrate our algorithm, our solution, is called a flow chart. And if we are just writing what we have to be done to reach the solution, is called a pseudocode. There are certain ways that we can illustrate this pseudocode and the flow chart. Now we are going to learn about what is the way that we are going to use that, right? So they have considered the very first example that we learned, the posting letter scenario. So they have taken it in simple terms now, the write in the letter, fold in the letter, insert in a letter into an envelope, write in the address, stick in the stamp, post in the letter, right? So as I told you, Tesandu, you will get to know about the algorithm soon, right? Tesandu algorithm එක කියලා කියන්නේ Tesandu අපි ඇත්තටම දෙන solution එක. Right? අපි දැන් අර උඩ කතා කරේ algorithms ම තමයි. But programming පැත්තට ආවම algorithm එක පෙන්වන විදිහ නැත්නම් solution එක මෙන්න මෙහෙමයි වෙන්නේ කියලා පෙන්වන විදිහ තමයි මම කිව්වේ ක්‍රම දෙකක් තියෙනවා කියලා. One is called the flow chart, the other one is called the pseudocode. Right? Is that clear, Sandu? Okay, right. So now when we are trying to map this thing into a flow chart, like if we are trying to illustrate our solution using a flow chart, we need some particular symbols to illustrate it. The thing is, we have to know what kind of symbols that you are going to use to illustrate this, right? So these symbols are given over here. Here comes the things as selections, sequence, selection, and repetitions. I'll come to these things, right? So before that, I'm going to show you the symbols. Right? So these are the symbols that we can use. Right? So if you are going to indicate a start or an end of a particular algorithm, every algorithm has a start and has an end, right? We indicate it using this oval shape, right? This is kind of a rounded rectangle, they have said, but it's better you use an oval, right? So that to indicate the start or an end, right? So we can draw an oval and we can write start inside it, if it is the start. And again, at the end, you can draw an oval and you can write end of the algorithm or the flowchart. And we have figured out the inputs and the outputs for a particular solution, right, when we are solving that problem. So those inputs and outputs are shown inside a parallelogram. So this is this symbol that we are going to use when we are illustrating an input or an output. Yeah, Sasrika, you can take the algorithm is a logic, as you say, that can solve a problem. Yes, that is a simple that is one of the simple explanation for an algorithm. Now, flowchart is like the way of illustrating it. Can you solution එක ඉදිරිපත් කරන ක්‍රමයක් flowchart එක කියන්නේ, right? So input and output can be illustrated like this, and the processes like the additions, subtractions, multiplications kind of things, right, can be taken as a process which will indicate inside a rectangle, right? And if you can remember, I have mentioned you some decisions to be made when we are talking about those examples, right? Like we figuring out that book example. If it is a 80-page book, it needs to be given to one particular sibling. If it is not, it needs to go give to some other. So that is a condition regarding the number of pages, right? And if you can remember the very last example that I asked you to write, so it indicates another selection, or like a kind of a condition that we need to go through, right? I'm talking about this particular thing, right? So you are going to figure out whether the remainder is 0, then you can figure it out. It is an even number. You are going to check whether the remainder is 1, then you can figure out it is an odd number, right? So comparing, figuring out the thing regarding a condition can be illustrated inside this symbol. We are using the diamond shape to indicate the decision. So inside this, you should ask the question which can always be answered as a yes or a no. Or නැහැ කියලා උත්තර දෙන්න පුළුවන් වෙන විදිහට තමයි අපි condition එක අහන්න ඕනේ. The question එක අහන්න ඕනේ. Right? Or like to have the answers like true or false. සත්‍යය අසත්‍යය කියලා කියන්න හරි. ඔව් නැහැ කියලා උත්තර දෙන්න පුළුවන් වෙන විදිහට හරි තමයි අපි ඔතනදී question එක අහන්නේ. So we have to make our decision into a question like that. Right? We will be doing those things, right? And then, since this is named as flowcharts, right? So it shows you how your solution is going to be flow. Right? So that flow is indicated by this flow direction. And we generally use a connector to connect a particular flow to some other flow. Again, where a solution generally එක page එකකින් එහා පැත්තට යනවා. එතකොට මෙතනින් ඉවර වෙන එක ඊළඟට connect වෙන්නේ මෙතනටයි කියලා indicate කරගන්න. On those cases, we can use a connector. Right. Okay, so those are the symbols that we can use for the flowcharts. And before we draw that, I want you to take the concentration to this as well. about the terms that we mention in the example: sequence, selection, and repetition, or an iteration. So sequence, as I told you, sequence is something which happens one after the other. එකකට පස්සේ එකක් සිද්ධ වෙන දේවල් වල තමයි අපි sequence එකක් කියලා කියන්නේ. Right? So as the explanation said, if the steps from the beginning to end of an algorithm are carried out in a strict order, it is called a sequence. So if you can remember in the envelope, the letter creating part, we had only sequence. We had things which needs to be done one after the other. Right? And if you think about the selection, the word selection gives you the idea about a particular condition. If that condition is satisfied, something to be done. If it is not satisfied, some other thing to be done. But somehow, based on the condition, it will flow on either of the path only once, and then they will probably come to a common position. Right? So it is something like this. Right? So as they say, admitting a child to grade 1, if the child is below 5 years and 31st of January that year, the child cannot be admitted to the school. If not, child can be admitted to the school. So it's a certain condition, and it has only one way of flowing. If the child is less than 5 years, he or she cannot be admitted. If not, can be admitted. That's all. Like like we decide the pass mark of a subject. If you score more than or equal to 35, it is considered as pass. If not, it's considered as fail. Right? And here they have taken you to buy a book. So if you got enough money, so you can buy the book. If you are not, you cannot buy the book. So it is always a condition which defines which activity that we are going to perform. And those activities, very importantly, done only once. Right? එක සැරයයි කරන්නේ condition එකට against. If it is true, there are a set of instructions to be done once, then it is done. If it is false, some other instructions are there to be done, then it is done. Right? So when it comes to the iteration or the repetition, there are certain set of things to be done again and again due to a condition. Right? So here they have considered about the process of class teacher marking the attendance register. Call the first name on the register, mark 1 if the student is present, mark 0 if the student is absent, call the name of the next student. So if there are 40 students, these 4 steps to be done 40 times, the same steps to be done 40 times. Right? So when some instruction happens again and again, according to a condition. Now, what is the condition? Until the 40 students are being covered, we have to do the register marking process. We can't stop at the middle, then our task is not fulfilled. We are not going beyond the 40 students if the class got 40 students as total, because we don't have the 41st student. In the class, 40 නම් ඉන්නේ 40 සැරයක් තමයි කරන්න තියෙන්නේ. ඊට එහා අපි යන්නේ නැහැ. හැබැයි 40ට කලින් අතර වෙන්නත් බැහැ. So we always check the condition whether the total count of the students are equal to 40. Right? If it is equals to 40, then we are going to stop. If it is not equals to 40, then we are going to repeat the thing again and again. Right? So likewise, inside an algorithm, you will find these three types. Definitely you will find sequence. Then, according to the situation, you will find either the selection or an iteration or a repetition, or both can be there. Right? So by next week, we are going to see how these things can be used to make our plan. That is using the flowcharts and from the pseudocodes. Right? So for today, I'm going to end the session from here. So by next week, we have some drawings to do. So get prepared with a pencil and an eraser, because there can be places for you to erase. Right? So prepare with that, people. So once we are done with our planning, we are going to do the codings. Right? So thank you very much for today. And I'll leave you from this point, and I'll see you on next week for the very same time. Right? So thank you very much, everyone. Have a very nice weekend.
Thank you.
Okay, Sasrika, we are having Pascal as the programming language in grade level.